Hi, in this video we're going to look at how to prove that a line is straight using vectors. So let's look at an example. The following diagram shows a triangle ABC. The line AC is extended to R, where C is the midpoint. The point Q is the midpoint of the line BC, and the point P lies on the line AB. The vector AC is given as the vector A, the vector AP as the vector 2b, and the vector PB as the vector B. Prove that the line PQR is straight. Well, in order to prove that PQR is straight, we have to show that the vector PR is a scalar multiple of the vector PQ. This is because vectors are parallel or have the same direction if both their x and y components are scaled by the same factor. For example, the vector 2, 3 goes along 2 in the x direction and up 3 in the y direction. If we multiply the x and y values by 3, we get the vector 6, 9. And as you can see, this is parallel to the vector 2, 3. So the vector 6, 9 is 3 times the vector 2, 3. But you can also say that the vector 2, 3 is itself a scalar multiple of the vector 6, 9 by multiplying the x and y components by a third. So in other words, the vector 2, 3 is equal to a third times the vector 6, 9, and so they're parallel. But in this particular example, we don't know the actual x and y components of the vectors. We're just told that the vectors are A, B, and 2b. But it doesn't matter, as we're still able to express these as multiples, as we shall now see. So let's first find the vector PQ. To go from P to Q, we have two choices. You can either go from P to A, then A to C, and then C to Q, or from P to B, and then B to Q. I'm going to choose the latter. So the vector PQ is B plus the vector BQ. We don't have the vector BQ, but we do know that Q is the midpoint of the vector BC. So PQ must be equal to B plus a half times the vector BC. The vector BC is equal to minus B minus 2b plus A. Therefore, BC is equal to minus 3b plus A. So the vector PQ is equal to B plus a half times minus 3b plus A. Expanding the bracket gives PQ is equal to B minus 3 over 2b plus a half A. Collecting the terms gives PQ is equal to minus a half B plus a half A. Note that we got minus a half B because 1b minus 3 over 2b is equal to minus a half B. Now that we have the vector PQ, we need to find the vector PR. This is minus 2b plus A plus another A. This is because C is the midpoint of the vector AR, so the vector CR is the same as the vector AC. Collecting the vectors together gives PR is equal to minus 2b plus 2a. We now have both vectors PQ and PR. To show that the line PQR is straight, we have to show that PR is a scalar multiple of PQ. And as you can see, if you multiply PQ by 4, you get minus 2b plus 2a. So the vector PR is equal to 4 times the vector PQ. As this is a scalar multiple, we've shown that the line PQR is a straight line. So that's how you can prove that a line is straight using vectors. If you found this video useful, please give it a thumbs up and subscribe to my channel where you'll find more videos for GCSE maths. Thanks for watching.